So let us take the example again. Series n equal to 0 to infinity 8 power 2n upon 3 power 3n. And so this is series n equal to 0 to infinity. This is 64 by 27 power n. Now what is a is 1 because n starts from 0. But r equal to 64 by 27. And 64 by 27 is greater than 1. Okay. And therefore the given series is not convergent. CGT rakhiye, CGT. Or you can say the given series is divergent. Given series is divergent. Okay. Next, let us see like this. Check for the series like 5 minus 10 by 3 plus 20 by 9 minus 40 by 27 and so on. Okay, this is one example. So now, can we write this in a way like this is pi, let us take outside, okay? So here we have 1, then minus 2 by 3 plus 4 by 9 minus 8 by 27 and so on. Okay, so this is equal to 5 and this is a like 1, then we write plus minus 2 by 3, then we write plus minus 2 by 3 square, then we write plus minus 2 by 3 cube and so on. Okay, so this is nothing but phi series n equal to 0 to infinity minus 2 by 3 power n. Understood? And now this is geometric series. What is a equal to? First term is 1. We are talking about this. First term is 1 because n starts from 0. And what is r? Minus 2 by 3. And minus 2 by 3. So modulus r is 2 by 3 and which is less than 1. Okay. And therefore given series is convergent. It's a geometric series convergent. R is less than 1. Modulus r is less than 1. So you can find now the sum also. And sum is what? Pi is there. A upon 1 minus r. So A is 1 and r is 1 minus, r is minus 2 by 3. Okay. So this is equal to pi 1 over 1 plus 2 by 3. So this pi cancel and this will be 3. Okay. 3 plus 2, 5. Pi cancel and this is 3. So now you can see that uh, even these kind of terms, infinitum, plus minus, that also has the exact sum, and that is nothing but 3, which is not possible to find exact sum here. Okay, so that is the main importance. One more example, let us see. Like find the convergence of series n equal to 0 to infinity minus 1 power n, then 2 here over 5 and 3 power n, like this. Okay. So now n is 0. So first of all, let us write this one as, we can write like this, 2 by 5 series n equal to 0 to infinity minus 1 by 3 power n. Okay, like this. And now we can see that this is a geometric series. And what is a? 1. And what is R? Minus 1 by 3. And modulus R is equal to 1 by 3, which is less than 1. So therefore, given series is convergent. And the sum is A upon 1 minus R. Like 2 by 5 is there. And A upon 1 minus R. So A is 1. And R is minus 1 by 3. So 1 minus minus 1 by 3. So this is 2 by 5. 1 over 1 plus 1 by 3. And so this is 4 and this is 3 here. So this is 3 by 10. Okay. So sum of the all the terms, all the infinity many terms, the sum is 3 by 10. We can have one more like this. Series n equal to 1 to infinity. See the in exam also. Here n begin from where? 1 or 0 kind of thing. Otherwise you will get the mistake. Okay. So 1 upon 2 power n plus 1 upon 5 power n. So here it begins from 1. That is main part. Okay. And you are having two series like this. Series n equal to 1 to infinity, 1 upon 2 power n plus series n equal to 1 to infinity, 1 upon 5 power n. Now here in this series, what is A? First term, 1 by 2, because n begin from 1. And what is R? That is also 1 by 2. Here A is 1 by 5 and R is also 1 by 5. So take care about this. N begin from 1. If n begin from 0, then A is 1. Okay. And in both the cases, modulus R is less than 1 because here 1 by 2 and here 1 by 5. So both the series is convergent. So sum of the convergent series is also convergent. Okay. So therefore, given series is convergent. And it's a geometric series also. Okay. So you can just write here geometric series. And what is the sum? Sum is A upon 1 minus R. So for first one, sum is 1 by 2 over 1 minus 1 by 2. For second one, it is 1 by 5 over 1 minus 1 by 5. Okay. So this is 2 minus 1. Okay. So this is again 1 by 2. So that is nothing but 1 by 2 divided by 1 by 2. And this is 1 by 5 divided by 4 by 5. Okay. So this is 1 plus 1 by 4. So 4 plus 1, 5 by 4. So total sum is 5 by 4 for this series. Okay. Next let us see series n equal to 1 to infinity 4 power n minus 1 minus 1 over 8 power n minus 1. Okay. Now here see the things are series n equal to 1 to infinity 4 by 8. Okay. Power n minus 1 minus 1 by 8 power n minus 1. Okay. So this is series n equal to 1 to infinity. This is 1 by 2 power n minus 1 minus 1 by 8 power n minus 1. So you have series n equal to 1 to infinity 1 by 2 power n minus 1 minus series n equal to 1 to infinity 1 by 8 power n minus 1. Now in this series and in this series, what is A? N begin from 1, but here you see n minus 1. So 1 by 2 power 0. So that is 1. And R is 1 by 2. Same way here. A, because n begin from 1, but here power is n minus 1. So 1 by 8 power 0. So that is 1. And R is 1 by 8. And in both the cases, this modulus R is less than 1. Okay, 1 by 2 and 1 by 8 both less than 1. So therefore, given series is convergent. If one is less than 1 and in another is supposed to greater than 1, so then also you can say that the given series is divergent. Then you can say the given series is divergent. Okay, both should be less than 1. Only then you can say that the series is convergent. Okay, so given series is convergent, and then you can find the sum. And sum formula is a upon 1 minus r. So a is 1 here, 1 minus r, 1 minus 1 by 2. Then plus here also 1, 1 minus 1 by 8. Okay, so this is 1 by 2, and here, so that will be 2. This is 8 minus 1, so that is 7, and here 8. Okay, and so you can have like this 7, 14, 14 plus 21 and 22. So that is the final answer and sum. Okay. Yeah, sorry. Here we have minus sign. So here we need to write minus sign. Here we need to write minus sign. And so here 14 minus 8. So that is 6 by 7. Okay. Okay. So this is about the geometric series. There are some applications. So one application is like this. Like express 5.23223 and infinitely. Okay. This is a rational number. You know, in 7-8 standard, that if the repeated values, then it is nothing but a rational number. So as the ratio of two integers. Okay, so let us express this as a ratio of two integer and using the geometric series. So let us see 5.23223 and so on. Can we write like this? 5, then plus 0.23223 and so on. Okay, 5 plus. Now can we write this as 23 by 100, okay, plus 23 by, say, for this 23 by 100, for this 23 by 100 square, because then it is 0.0023, okay, plus next 23 by 100 cube, and so on. Understood? 0.23 we can write as 0.23 plus 0.0023 plus 0.000023 and so on. So for this we write 23 by 100, for this we write 23 by 100 square, for this we write 23 by 100 cube and so on. Okay. But now we see this is a geometric series. Okay, again we take like this. 5 plus, let us take 23 by 100 outside. Okay, so here it is 1. 23 outside, 100 also outside. So this is 1 by 100. 23 outside, 100 also outside. So this is 1 upon 100 square, and so on. And so this is a geometric series. And so, and then A is 1. and R is 1 by 100, which is less than 1. And so that is convergent. So what is the sum here? So sum equal to pi plus 23 by 100, A upon 1 minus R. So 1 upon 1 minus 1 by 100. Okay, and then we simplify. Pi plus 23 by 100. This is a 99 and 100 here. So 100 cancel. So 5 plus 23 by 99. And then simplify this 99 into 5 and plus 23. So you will get 518 upon 99. So this is 5.23232323 is nothing but 518 divided by 90. Okay. Okay. Let us take one more example. That is application of geometric series. Like this. It says like this. You drop a ball. Okay. From where? So from a meter. Okay. From a meter above a flat surface. Now, there is one rule. The rule says like this. If you drop a ball h meter, okay, from means above a flat surface, h meter above flat surface, say suppose. It rebounds RH meter, where 0 less than R less than 1. This is a rule. It says that if you drop a ball h meter from the above the flat surface, it rebounds RH meter, where R is 0 less than R less than 1. And we are dropping the ball from a meter above the flat surface. Okay. And so the question is here in general, find the total distance. Find the total distance traveled. It may also given like this. Suppose say A is 10 and suppose R is 1 by 2. Then what is the distance, total distance covered by the ball? 10 meter above the flat surface, and each time it rebound R into H. So R is 1 by 2 given. So let us say see like this. Suppose say this is a flat surface and from here we are dropping the ball first time. So suppose 10 meter. So we drop the ball here and it is 10 meter. Now what it says, if you drop a ball h meter above the flat surface, it rebounds RH meter. So in our case, suppose we are talking about say 10 and 1 by 2. So it rebounds 10 into 1 by 2. So it rebounds like this. Okay, like 5 meter. 10 into 1 by 2. Okay. And again, now we drop a ball from 5 meter above the flat surface. So it come here and again it rebound like this. Okay, 5 by 2. 5 by 2 meter, because now our h is 5 and RH is 5 by 2. So again it comes to the surface and again it rebound. Okay. Again come to the surface, again get rebound. Again come to the surface, get rebound. Again come to the surface, get rebound, and so on. Okay. Friction, due to friction it will stop. But as a theory, we can say that it continues and go on. Okay. So then the question is how much total distance covered. So in our case, suppose generalization if we talk, then it is A. First, this distance is 10. So this is A. Next distance is what? AR. This is A. This is AR. But AR how many times? 2 times. Because it goes AR here and again come down AR here. So AR will get 2 times. Now what is next? Here AR. So this will be AR square. And again it will come down AR square. So again that will be 2 times AR square. And so on. Next it will be AR cube 2 times. Because once it goes up and then it goes down. Only the first time it is A, but otherwise rest of them it is 2 times. Okay, and continue. And so this is the total distance. A plus 2 times AR plus AR square and so on. So that is A plus 2, even AR also you can take common. So this is 1 plus A common, 1 R is common, so this is R. A common, R common, so R square and so on. And this is geometric series. And R is less than 1. So that is convergent. And so what is the sum here? Sum means total distance is A plus 2AR. First term is 1 upon 1 minus R. So this is the total distance covered. So like A into 1 minus R plus 2AR upon 1 minus R. So this is A minus AR plus 2AR. So plus AR upon 1 minus R. So this is A into 1 plus R upon 1 minus R. This is the total distance covered. Okay. And now if I take A to be equal to say suppose 10 and R equal to 1 by 2, you will get the answer for this particular case. Okay. So for A equal to 10, R equal to 1 by 2, you will get total distance is A is 10, 1 plus 1 by 2 upon 1 minus 1 by 2. So this is 10, this is 2 plus 1, 3 by 2, and this is 1 by 2. So to cancel, so 30 meter total distance cover. If you drop a ball 10 meter above the height, above the flat surface, and each time it gets rebound half, that means 1 by 2, then total distance covered by that ball up down is 30 meter. Okay. One another question is also there. It's a good application here also. So it is like this. There is a sequence of squares like this. So we have one square. Okay. And outermost square has the area of 4 meters square. So the area of this square is 4 meters. Okay. Now the things are each of the other square, remaining square, there are infinitely many squares, but how other squares are there? Each of the other squares is obtained by joining the midpoints of the sides of the square before it. So next square is how you are having. So here there is a midpoint, here midpoint, here midpoint, here also midpoint. So you join this midpoint, join the midpoint, and it will be having a join the midpoint here. So one more square here. So outer square, then this one. Now what is another square is also here again. Just join the midpoint. So these are the 4 midpoint. So like this. Next square is also you will get like joining the midpoint of this one. Next square is also there by joining the midpoint of this one. Like this. Next square is also there by joining the midpoint of this square. Like this. This process goes on, goes on, goes on infinitely. This is again you will have, then again you will have, and so on. Continue this process infinitely many times. Okay, this process is you will have infinitely many times. Agree? The question is find the sum of the area of all the squares. Only outermost square area you are given. then you are not given the area of that inner square, not given the area of again inner square, inner. So the question is find the sum of areas of all the squares. Okay. So the first is what? The outermost square area is 4 meters square. Square is there. So side length is 2. Okay, that is the first thing. So you can write that the area of outermost square is say 4 meters square. So length of side 2 meters square. Okay, because that is 2 square. That is the thing. Now what we are doing? We are doing like this. See, now we find the area of square inside this. We would like to find out the area, but then we need to find the length of the side. Square is there, but we need to find the length. And length is what? So here you can say that this is S. This is nothing but say S. S is 2. S is 2. And this is say, suppose S square. Okay. Now, new square is what? This side is S by 2. And because midpoint is there. And this is also S by 2. And this is a right angle triangle. So I can find the side length of this square by Pythagoras theorem. Okay. So the side length of next square inside. Okay. So Pythagoras theorem we use, and that length is nothing but root of here S by 2. This is also S by 2. So S by 2 square plus S by 2 square, because this will become a uh, hypotenuse. Okay, 90-degree angle here. So this will become a hypotenuse. And so that is nothing but S square by 4 plus S square by 4. So 2 times. Okay. So this is a S square by 4, 2 times S square by 4. So this is S square by 2 and its root. And so nothing but, okay, that side is nothing but root of S by root 2. S by root 2. Okay. So in our case, S is 2. Okay. Here S is 2. So the length of the square inside, okay, inside square is nothing but 2 by root 2. And so that is nothing but root 2. Length, root 2. Okay. So you have total sum of area. Every time you will get like this. Here 4, so length 2. Then here you are having length is root 2, or you can say the area is 4 here. Now length is root 2. So area of that square is 2. Inside again you will get still half of that. So that area is nothing but 1. Again inside you will get half of that area. That is 1 by 2. Still you will get half of the area. That is 1 by 4. Area becomes half. That's what we put. Okay. So now sum you will get. Total sum, because this is the geometric series. Okay. This is nothing but the geometric series. So what is A here? 4. And what is R here? 1 by 2. Half થઈ જાય છે. So sum is nothing but A upon 1 minus R. So that is 4 upon 1 minus 1 by 2. So that is nothing but 8 square meters. So outermost square area is 4, and the total area of all the square, all the infinitely many square is nothing but 8. Okay. So that is the way you are having the kind of examples of geometric series. Okay. If you want, we need to sit one more time and